So 7.5 glide reflections. And compositions. All right, so these first ones start us out nice and simple. They say to sketch the image of A, which it gives us the point, and then after the described glide reflection. And so I've got the point A is negative 3, 5, and that's true for all of these problems that we're about to do, 12 through 15. Number 12 says it's a translation from xy to xy minus 4. And then it's a reflection in the y-axis. So I think just to make sure I have enough space, I'm going to go down here. All right, so I'm going to plot the point negative 3, 5. So notice these ones aren't like lines or anything. This one's just a point that's getting put on here. So the point negative 3, 5 would be here. Then it's being translated, we're going in order, from xy to x and then y minus 4. So that means that the x value is staying the same, the y value is getting shifted down 4. So that means I'm going down 1, 2, 3, 4, and this would be my A prime. And it might be good to even write up here that like that's what that transformation is showing. Then it's a reflection in the y-axis. So that means that it's coming over the y. So if this is negative 3, positive 1, then that means that this is going to positive 3, positive 1. So the x value is what is changing. So that would be your A double prime, which is your final thing. Uh, 14. So we have the same A point, the negative 3, 5, and then it says it's a translation xy to x minus 6, y minus 1, and then it is a reflection in x equals negative 1. So I'll kind of show you what I would recommend with one like this, but obviously this one's not being reflected on an axis, so it might be beneficial to almost put like a dotted line, maybe in a different color or something, where that x equals negative 1 is on the graph. So when you go to reflect it, you make sure you're like the same distance from your like line on one side as you are on the other, since it's not just like the middle of your graph. But I'll show you what that would look like in a second. So I'm going to set up my graph here again. I feel like I might be making this really large, but we're just going to go with it. So my initial point, negative 3, 5, up here. And then it's being translated. So the x value is going to subtract 6, and then the y value is subtracting 1. So that just means that I need to, basically from here, I need to go back 6. So 1, 2, 3, 4, 5, 6. And then the y value says to go down 1. So that just means put it down here. So I don't even have to like find exactly what they are. I can just take and just like move the point over and down. And so this would be my A prime. So now it's reflected in x equals -1. So I need to see how far away this point is from x equals -1 in order to be able to reflect this. So x equals -1 is here. So where do you think this might need to go? How far away are we here? Wait, 1, 2, 3, 4, 5, 6, 7, 8. Wait, what?
It'd be 9.
No, from here.
From X.
Did I count right? Hold on. This is -3. 1, 2, 3, 4, 5, 6, down 1. Okay. I think they just have a typo then. Oh, never mind. I know what I'm doing. So this is, okay, so distance away here. 1, 2, 3, 4, 5, 6, 7, 8. So I'm 8 away on this side. So that means I need to go 8 away on this side. So 1, 2, 3, 4, 5, 6, 7, 8. So that means I have a point there. It doesn't change the y value. This is just like if it was over the y-axis. This is just over the line x equals -1. So this would be a double prime. The reason I was questioning if I graphed it right is because it told me what the coordinates of this was in the book, like the final answer. And I was looking at it, and it said it was at 7, 4. And I was like, but that's not 7 away. And then I realized, oh, it's because it's over here. So I just wasn't counting correctly. So the book is looking for, like, the final coordinates of this, but if you've graphed it and stuff, like, I should be able to see, like, where that is. So as long as I can see, like, where it is, that's fine. And so just to go back, this one, I think we said it, but this one was at 3, 1. The previous one. Okay, next ones are going to give us a triangle. So 16, sketch the image of triangle PQR after a composition using the given transformations in the order they appear. So P is the point 4, 2. Q is 7, 0. And then R is 9, 3. And it is a translation. I'm not going to write the whole word out. TR for translation. XY goes to x minus 2, y plus 3. And then the rotation. Since reflection and rotation both start with R, I would say just like use the second letter if you don't want to write the whole thing out. So 90 degrees clockwise about the point T, which is 0, 3. Okay, so this looks like for the most part my graph is on like the right hand side. Everything's in the positive. So I'm basically just going to make a big graph like over here. All right, so I'm going to do the initial, and if on this section, if you want to use colors so that you can show the stuff how they did with like the blue, red, and the green, like how I am, you're welcome to do that with this section. Obviously, normally we don't use pen, but if you want to help you see this stuff, you can with this section. So I'm going to plot each of these points. Make sure you label them. So the point 4, 2 is P. Q is 7, 0. And then R is 9, 3. So then obviously at that point we need to connect them for our triangle. Now the next step is to translate. So every single point I'm going to do the translation on. So this is going to go left 2, up 3. So I'm going to start with P. Left 2, up 3. And that's going to be the prime R, left 2, up 3. And then Q, left 2, up 3. All right, and so then we are rotating it 90 degrees clockwise. So I'm not going to be like super picky about making sure that you're like exactly, right? Like you don't have, well, you might have a protractor, but we're not using a protractor. Like obviously a rotation 90 degrees, like it should look approximately 90, but I'm not going to get out a thing and like measure it and make sure that you did it like exactly. So I would say take this point here and draw like a line there. And then I would try to make like a 90-degree angle here for what that looks like. Again, it's going to be approximate. Not going to be like crazy picky about it. But basically this was up 3 over 1, 2, 3, 4, 5. So this should probably be like down 3 over like 1, 2, 3, 4, 5. So it probably should really be like over here, that first point. But I'm not going to be crazy about it. I'm not asking for like all the coordinates with these.
I thought it said to do a 90 degrees clockwise around point T, which is 0, 3.
Good catch. It does say that. I'll put it up there in a second. Okay, correction. It is about the 0.03, which will actually probably make this problem easier. So I'm going to throw point T on here really quick, which is 0.3, so that's up here. So this is then where we would want to come from. It's basically just the point that's closest to it, and then that means that basically this is up 2 over 2, so I would go like down 2 over 2 like that. And so that means that this is going to be the point, I am going clockwise, right? Oops. This is going to be the point P double prime. And then to get to Q, it is, this might be where it's helpful to have like another piece of paper when you're rotating it. So then Q would be down 1, 2, 3. Hold on. 1, 2. Q double prime. Hold on. 1, 2. Back 1, 2, down 3. Yeah. So basically the point Q, we'd go back 2, down 3. And then R would be like, let's see, up 1, 1, 2, 3, 4, 5. Whoa. Everything just disappeared. Yeah. Basically, R double prime would be over here around our Q value from our original one. It doesn't look quite the same, but it's close. Oh, wait. Hold on. R's in the wrong spot. Come on. So, R would be, let's see, down, wait, over 1, down 5. 1, 2. Here we go. R should actually be down here. There we go. There's your R double prime down there. I was looking at it and I was like, it doesn't look right. Again, I'm not going to be super picky. You're going to get it in the right general vicinity, make it look approximately right. That's what I'm looking for. Okay, we're not stressing too much over the exact points. Now, reflection should be a lot easier because we're just changing the value. Rotations are the ones that I'm talking about. I'm not going to be as picky about. Okay, because those ones are hard to see unless it's like literally attached to something. It's really hard to tell what they are. All right, 18. Actually, we're going to jump down and do 20 instead. 18 is just a double translation, so it's just getting shifted once and then it's getting shifted again. That's why I was like, I'm just going to jump down to 20. Sketch the image of FG after composition using the given transformations, then perform the transformation. Oh, we're not going to do the reverse order part. We're just doing the going forward part. So F is the point 4, -4, and G is the point 1, -2. So it's a rotation 90 degrees clockwise about the origin. And then it's a reflection in the y-axis. So rotations for these ones should be easier because obviously it's just a line and not a whole triangle. Okay, so point F is 4, -4, so that's going to be down here. G is 1, -2. So it's being rotated about the origin, so I'm looking at going from here to basically going through here. Not getting crazy picky about it. Something roughly like that. So then that means that this would be G prime. And then to get to F from there, it would be going up to right 3. So I'm just basically looking at like the slope of the lines here to get the approximate value. And then it's reflected in the y-axis, so which way is it going? Is it going left or is it going down?
Left.
Yep, over the y-axis means it's going on this side. So we just need to go the same distance away. So this is 2 away here, so it needs to be 2 away on this side. G double prime. And then F double prime, we're 1, 2, 3, 4, 5 away here. Hold on. Yeah. So that means that I need to go 5 away on this side. So 1, 2, 3, 4, 5. That's F double prime. And we're there. Now, like I said, they say to also go in reverse. We're not doing that. We are just doing the like going in the forward direction part. Any questions about that? So again, don't stress too much over this stuff. I'm looking for an approximate. I'm not looking for the exact. Like now, the ones with the points, we should be pretty accurate on those ones with the points. But these ones that are like the rotations, reflections of like lines and triangles, I'm not getting crazy picky about them. Okay? It's just getting it in the right general vicinity and all of that. All right, a couple problems. Now, today is Wednesday, so you'll have time tomorrow to work on these. We are having a quiz on Friday. Or, wait. No, we're not. We're not having a quiz on Friday. You might have some time tomorrow to work, but we might also start the next section. I haven't decided yet. Or we might have time to work, and I might talk to you about the rest of the tessellation project that we're going to do. You probably have a quiz next, either Monday or Tuesday. 13... 15, so those are the ones just with the points. 17, and 21. So just 4 problems, shouldn't take you too long. That's why I said we'd probably give you a few minutes tomorrow to do them. The first 2 should be the easiest ones, and then obviously 17 and 21 will be a little bit more involved. Just go ahead, it's fine.